Welcoming back to MSD Learning World. In this video, we are going to see NFA EPSILON Machine. What is NFA Epsilon? NFA Epsilon, it is a non-deterministic finite automata with epsilon transition. What is mean by epsilon? Epsilon is nothing but null input. Even the user is not giving any input. The machine must be in a state to perform transition to any other state. So for example, here we have a machine which is a finite automata machine. So this machine consists of an initial state P and final state R. And this machine have the input alphabets 0, 1, 2. Along with 0, 1, 2, it has an input as epsilon. So here, what is the speciality of this machine? Even if I am not giving any input to this machine will be reaching the final state. Without giving any input, the machine will be in the initial state at the very first time. It will be, if I am giving 0, this state will remain in the same state. If I am not giving any input, after some period of time, it just go to the state Q. If I am not again giving the input, it again go to R and reach the final state. So here, this machine will reach to the final state even if the input W equal to epsilon or the null value. This is what is the NFA epsilon. So why do we want to have this type of machine? Let us see the application of NFA epsilon after we are seeing the description of this machine. So this NFA epsilon, non-deterministic finite automata with epsilon transition, consists of set of all states with single starting state and set of final states. In any finite automata, it can have any number of final state. And the input alphabet here is concatenated with epsilon value. The machine components are Q, sigma, del, the initial state. Initial state here is P and the final state. Here, what is the difference? All the components of the machine are the same. How the machine NFA epsilon differ from DFA and NFA? Here, the NFA epsilon differ from the input here will contain epsilon and that there will be a transition for epsilon. So here, sigma, the input and the transition function will differ from DFA and NFA. So here in this machine, the set of all states will be equal to P, Q and R. And sigma will be equal to sigma union epsilon, which will be nothing but sigma star. And del will be defined as Q Cartesian product sigma star tends to 2 power Q. Here it differs in the sigma star. Sigma star is nothing but a star closure which is along with epsilon. And the initial state is P and the final state is R. So this is what is the machine description for NFA epsilon. Now, how we are going to represent this transition diagram in transition table? P, 0 goes to P. Since it is NFA epsilon, we are going to have set of all brace. Then P, 1 is empty. P, 2 is empty. P, epsilon in the transition table, you have to specify as P on epsilon transition goes to Q. Now Q on 0 empty. Q on 1 remains in the same state. Q on 2 empty. Q on epsilon go to the state R. Now R on 0 empty. R on 1 empty. R on 2 remains in the same state. R on epsilon, it is empty. This is how you represent the transition table where P is the initial state. P is the initial state marked with the arrow mark and R is the final state, so marked with the star. When you consider this NFA epsilon, there is one more property called epsilon closure of any state. So what is mean by epsilon closure? Epsilon closure of any state is the set of all state. For example, epsilon closure of P will be equal to set of all states for which there will be a transition for epsilon till the final state. So for example, it will be a set of all state x, where x will have any number of states for which p will be going to those set of all state x for epsilon transition. For example, when we consider this above automata, so epsilon closure of p is nothing but consists of set of all states where there is an epsilon transition from p to that state, and that epsilon closure will also include that state. So epsilon closure of p will be equal to p. So now from p, where it is going for epsilon transition, to q, again from q where it is going for epsilon transition, r, from r it is not moving for epsilon transition. So you have to close the set. Now epsilon closure of q, first include that state. Then from q, is it having epsilon transition? It is going to r. From r, is it an epsilon transition? Is there any move for epsilon transition? There is no epsilon transition. And then what is epsilon closure of r? Epsilon closure of r will include that state. From r, it is not going for epsilon transition. So with r, you are closing the set. So this is how we will be seeing the epsilon closure of any state. So epsilon closure of any state will include a set of all states for which there is an epsilon transition from that state to the given set of states. So now what is language of the machine NFA epsilon? So the language of the machine is the set of all strings accepted by the NFA epsilon. So the language of the machine M consists of set of all strings W, where del dash of extended transition function, del dash of the initial state comma W contains a state in F, and also you can also tell the language of the machine M equal to W, where del dash of Q comma W contains a state in F. Here it is intersection final state does not equal to null set, where the W will be including W union epsilon. So this is how both the conditions will be coming under your NFA epsilon. So the language is nothing but set of all strings W, where del dash of the initial state comma W intersection final state does not equal to empty set. So this is what is the main descriptions of the machine NFA epsilon. Now let us see an real-time example for NFA epsilon. So which application you need NFA epsilon machine? So for those application for which you need to perform any action for which the machine must go to a next state even without getting the input. So for example, when you take, suppose you assume that you are opening a notepad, you are in an initial state P, you are opening a notepad, so you are just pressing open, assume open is you are pressing open, so open is denoted with 1 and your document is open now, it is going to the state Q. Then after that you are typing some content and you are pressing save. Assume save is the input which will have the symbol 2 and it is going to the state R. Now after going to the state R, if you are not giving any file name, then even by giving epsilon input, it will go to the state S by making your document to be saved with the title as untitled.txt. I think you would have experienced this when you open a notepad. Not only notepad, any document, any Microsoft application document, any programming language, editing window, anything, any window if you open and if you try to save it and if you are not giving any file name, then untitled.document will be created. Untitled, or if you are again opening another new file and if you are not giving a file name, then it is untitled 1, untitled 2. Like that it will be keeping on increasing its number. So there are some machine which needs this NFA epsilon to perform some action even without giving epsilon input. Now let us see another example. Suppose if you are opening an Internet Explorer or Chrome, if you are opening a Chrome and if you are not giving any title, any website in your title bar, then directly it will be going to either msn.com or google.com. So there, without even giving an input, for epsilon input also, it is going to some of the websites. So for any examples, like there may be when you are using a mobile desktop window, you want to get inside without password. Even without going to password, directly if your WhatsApp should be opened. So for epsilon input, without giving the input, if you some action has to be performed in your application, you go for having NFA epsilon machine. So these are all some of the examples of NFA epsilon machine. I think you understand what is meant by non-deterministic finite automata with epsilon transition. So this non-deterministic finite automata is similar to with the epsilon transition is similar to an NFA, which has a non-deterministic property where a single state will have one or more transition for a single input symbol. Along with the NFA non-deterministic property, it will be performing a transition to any other state even without giving an input. That is what is NFA epsilon. I think you are clear with this. If you have any other doubt, you just comment on the channel. Do not forget to like, share and subscribe the channel. Thank you.